Okay, so in this video, we're still on the paper of NSC February-March 2014. Okay, so now what's important to understand, we're going to now do 9.5. So in 9.5.1, we're going to read. So just follow as I'm reading. An unknown resistor is now connected in parallel with the 4 ohm and the 1 ohm resistor. Now remember, they're saying that a resistor is connected in parallel to the 4 ohm and 1 ohm resistor. I want you to understand the following. That the general rule is, so this is a general rule, okay, of resistors. So if resistors, or I'm going to call it an extra resistor. If an extra resistor is connected in series, it basically increases the effective resistance. And when extra resistor is connected in parallel, it's going to decrease effective resistance. So what do I mean by this? What I mean by this is that, let's say for example, you have two light bulbs. That's two resistors, 2 and 2. Now 2 plus 2 is 4, right? If I add an extra resistor, 2, 2, 2, the total, so here RS is equal to 4, but here RS is now equal to 6. So you can see that if we add a resistor in series, in a series circuit, so when an extra resistor that's connected in a series circuit, you are increasing the effective resistance in a series circuit. But if an extra resistor is connected in parallel, so let's say for example you have a parallel circuit, let's say that's 1 and that's 1. So here we got 1 over RP is equal to 1 over 1 plus 1 over 1. So 1 over RP is 2. So therefore RP is equal to 1 over 2. But if we add another resistor, let's say we add another resistor, also 1, RP is actually going to be equal to 1 over 3. And you will see that the effective resistance decreased from a half to 1 over 3. But here the effective resistance increased from 4 to 6 if resistors are connected in a series circuit. Two resistors in series. So in this example, they told us that a resistor was added in parallel of a resistor with unknown resistance was connected in parallel to the circuit. So that means that R external decreases, or rather we can say RP decreases, but essentially what's happening is that the effective resistance here is going to decrease because there's an extra resistor connected in parallel. Now if you look at this if you look at this graph here, the first thing that you must know is that V total and R internal remains the same, remains constant. You can actually mention that at the start for your examiner if they ask you to explain why, which I think that's 9.5.2. In fact, 9.5.1 says, how will this change affect the magnitude of the internal resistance of the battery? The internal resistance of the battery will remain constant. So your answer by 9.5.1 will be remains the same, because we are not taking away a battery or adding batteries. Let's move on to 9.5.2. Before I go to the question of 9.5.2, I first want to analyze what is happening. So R external decreases. Now, can you see here that I want you to understand that if you have an equation, for example, x is equal to y plus y plus 1. Okay, now let's say, for example, if y increases, what's going to happen to x? X is going to increase. So if the two variable and 1 is a constant, so if there must be a constant if you want to describe a relationship between two variables. So if the two variables are on the opposite sides of the equation, if one increase, the other is going to increase. If one decrease, the other one is also going to decrease. But if you have, for example, 1 is equal to x plus y, and y increase, what's going to happen to x? X is going to decrease. So if they're on the same side of if they're both on the right hand side of my equation, if one increase, the other one is going to decrease. If one decrease, the other one is going to increase. That's the variable is going to increase. But if they're on opposite sides of the equation mark, if one decrease, the other one's going to decrease. If one increase, the other one's going to increase. Just make a note of that. So do you see here that R here is our constant? So if R external decrease, R total will also decrease because they are on opposite sides of the equation. If you look at this row now, so number 1, R external decrease. Number 2, R total decrease. If you look at this row over here, V total is here now our constant in this row. And I total, so if R total decrease, what's going to happen to I total? I total and R total is on the same side of the equation. They're both on the right hand side. So if R total decrease, I total will increase. And that's what you did. That's number 3. Number 4, do you see that if I total increase, I external will increase and I internal will also increase because they are all equal to each other. If you look at this row over here, if R is a constant and I internal increase, V internal will also increase because they are on the opposite sides of the equation of the equal sign. Then if you look at this column over here, if V internal increases, V external will decrease because they are on the same side of the equation. And V total is a constant. So what does the question ask us? The question asks us the reading on the voltmeter. So will the reading on the voltmeter increase, decrease, or remain the same? So the voltmeter is there, and the voltmeter reads the voltage across the 1 ohm. And the voltage across the 1 ohm is 2,8 volts, right? And that 2,8 volts was also the external voltage. So the voltage across the 1 ohm also reads the external voltage, because if you have V external and if you have this V external entering the parallel circuit, the same amount of voltage is going to enter branch 1 and branch 2. So if you read the voltage over the 1 ohm resistor, you're actually reading the external voltage. And we see here that our external voltage decreases. So your ultimate answer will be decreases. But what do you tell your examiner? And I'm going to show you now. You basically tell your examiner everything that you illustrated here. So you're going to tell your examiner R external decreases. Tell your examiner, then R total decreases, then I total increases, then I external increase, then I internal increase, then V internal increase, and therefore V external decreases. You have to do it in order as how we did it here, okay? And that's how you will get your full marks, right? And that will show you understanding, that you understand what you did. But the ultimate answer is decreases for the external voltage. And I just explained to you how we got it. Peace. Thank you everybody for watching the video.